Okay, so let us welcome our speaker for the day, Mr. Akshay Bhadage. थोड़ा सा मैं briefly introduce करता हूँ. Some of you know him already. तो सर, first of all, it's a thing of proud for us कि हमारे दूल्हे के ही है. He did his BS plus MS dual degree from ISER Bhopal in 2020. Then in 2022, he went to Germany, University of Jena, to do masters in photonics. तो सर का अभी रिसेंटली मास्टर्स आई थिंक थीसिस अभी सबमिट हुआ है, सो ऑलमोस्ट कंप्लीटेड एंड ही हैज़ ऑलरेडी जॉइंड समवेयर, ही इज़ वर्किंग समवेयर. So today we have the honor that Akshay sir is with us. So he will be talking about the photonics and what are the future scope for this particular topic. Over to you, sir. Thank you.
Thank you. So I will start.
Yes.
Hello. Can you hear me at the back? Can you hear me? आवाज आ रही? आवाज? Okay. Okay. So today we will discuss research happening in photonics and some of the career opportunities. Okay. So the outline for today's discussion will be I will introduce myself, then we will see how photonics started, particularly in the city where I'm studying right now, and the research areas in photonics and career opportunities, how you can also go to Germany or Europe for your studies and jobs. Okay? So, just let me introduce myself properly. So, my name is Akshay. I completed my master's in physics and then I went for a second master's in photonics to Germany. And currently, I'm working with Quantum Communication Group at Fraunhofer IOF, ENA. So, this is spelled as JENA, but in Germany, J को E pronounce करते हैं, okay? So that's why I'm saying ENA. So throughout the talk, when I'll be saying ENA, it is JENA, name of the city. Okay, and you can also check out my profiles on my website advancedphysics.academy/about. आपको like मेरे सारे जो social media जो भी handles you can check there. So let's get started with what is photonics. So आपको पता है that light is an electromagnetic wave. Okay, 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 and also it exists in two forms, that is wave as well as particle. Okay, so light का there is a spectrum, wide spectrum. So on the left side here, it is like radio waves जिनका wavelength होता है in the range of meter, right? Like long wavelength होता है. And then we have microwaves, infrared. At the center we have visible. What is the range of visible light? Wavelength here 400 to 700 nanometers. Yes, please. And if you go to the other side of the spectra, we will have ultraviolet, X-ray, gamma rays. Okay. So this side, on the right side, we have high energy, and on the opposite side, low energy. Okay. And now, when optics started, it was it was only for visible spectra, because like 400-500 साल पहले we didn't have tools to see the other spectra, so only visible light के साथ लोग experiments perform करते थे. Okay, so optics as it started, you already know reflection of light, refraction of light, है ना? And then you also know आपने किए हुए experiments prism के साथ, like dispersion of light, white light enter कर रहा है यहाँ पे, and then it is getting resolved into its components because each wavelength experiences different refractive index, so dispersion हो रहा है. So this was like back then, and also आपको ये भी पता होगा lens equation 10th standard 11th, right? Okay, so this was like geometric optics with lens. As the time went by, technological advancement हुआ, and then people were able to study wider range of the spectra, right? Like we can study infrared, microwave, ultraviolet. So photonics firstly deals with wider range of electromagnetic waves than traditional optics. जो पहले optics था, like people used to make lenses, telescope, microscope. उससे आगे जाके now we are studying wider range. This is first thing. Second thing, we focus on technology. So earlier we didn't care about how the light is generated, how it is detected. So now this is taken from Fraunhofer IIF website. So on the left side we have entangled photon source. So light generation पे भी focus होता है photonics में, and then we also have focus on detection of that light. So as small as we can generate single photon. एक photon का like how do we calculate energy of photon? E equals mc squared, that is for particle. But for radiation, which is massless, we have E equals Planck's constant, yeah, h nu. Exactly. So single photon ka energy will be very very small because h itself is very small, 10 to the power minus 33 times nu hoga like 10 to the power 15. So it is very low. So even then, हम generate कर सकते हैं single photon, and also we can detect that single photon. It is possible. Okay, so photonics deals with this kind of problems. Ki how do we generate single photon? How do we detect it? And also we have advanced application like lasers. फिर quantum mechanics का use करके how can we communicate? Quantum communication. Okay, so these are some of the research work happening at Fraunhofer, and also we can perform computations. Quantum computers सुना होगा आपने? Quantum computers. So like this computer, this thing, it is based on electronics, right? Electronic circuits, integrated chips है इसमें. We can also perform computations using light and quantum properties. So that will be quantum computation. So in short, like in the single line, if you want to describe photonics, it is study of light and its technological applications. Okay, okay. And 20th century में we focused on electronics. That gave us what? Computers, mobile phones, electronic devices. Now in 21st century it will be for photonics. People are exploring how can we perform same like technological advancements using photonics, photons, light का use करके we have to develop new technologies. Okay, so let's quickly briefly look at how it started in Vienna, history and the current state. So photonics research is happening throughout the world, but since I'm working in Vienna, I will only focus on Vienna. And also, yeah, we'll see. So firstly, Vienna, this is Germany's map, okay? And at the center here, center of this triangle, this is Vienna. And all these blue dots, actually, they are research centers for photonics, okay? Currently, Vienna looks like this, but when it started, it was different. Okay. There is this University of Vienna, Friedrich Schiller University of Vienna. It started in 1550s, and since then they were focusing on science and all. And Carl Zeiss, he came in 1800s, and in 1846 he started Zeiss Group. Zeiss नाम सुना है? सुना होगा. Do you know influence of Zeiss is in UA as well in our city? आपने notice नहीं किया? Have you? So other day I went to make the specs. I was standing there. I took this photo. If you look closely at this thing, there is ice. So something that started like 200-300 years back in Vienna, unka influence is there in this. Like our city is not that big, right? Still, it is there. Their presence is here. They make glasses of glasses. Yes, specs are glasses. Okay, so yeah, like power of science, innovation, technology. You know? So okay, and when he started, he was focusing on making microscopes. So no existing, he didn't invent it, but he made better microscopes at that time. Okay, cheaper and better quality. Germans always focusing on technology. And then he was joined by later on Ernst Abbe. Abbe equation, do you know? Okay, maybe it will come later. It's fine. And Otto Schott. And yeah, so these three pioneers developed economy, like this science economy in Vienna, focusing on photonics. And today, so we see that this is my campus. Here on this side, we have Fraunhofer, which is Abe Center of Photonics. This is Max Planck School of Photonics. behind is IPHA, so many research institutes. Overall, they have about 200 startups and companies. And बस येना का turnover जो revenue है only based on photonics, okay, it is about 4 billion euros. So that level they built in 200 years. They focus on R&D. So like Germany में एक rule is most of the companies they follow 15% तक वो R&D में invest करते हैं for research and development. Okay, not on marketing but on R&D they invest. They export mostly. Most of their products are exported. And Jena is a small city actually. बस 1 लाख 1.25 lakh तक लोग हैं and 30-40,000 the students here. Out of the working class, like one third of the working people, they are involved in photonics industries, and it is always growing ever since. These are some of the companies and startups in Jena. So they develop really well based on this photonics science. So yeah, like through this talk, it is my wish that I will give you this knowledge, and hopefully many of you will join photonics, do research, and will be able to contribute to our economy through photonics and science. Okay, so let's quickly also look at research areas in photonics. Okay, so the type of research happening. Uh, I will not cover all the like. See, there are many. It is diverse topic, and many research institutes are there throughout the world. I will just focus on जो फ्रॉनऑफर में काम करते हैं. I will focus on that. That itself is a lot. You can check more. Like you just have to search photonics research happening throughout the world. ठीक है, आप कर लेना बाद में. For now, we will just focus on some particular topics. So photonics has applications in diverse areas such as aviation, physics, health. So there are like topics such as medical photonics. आपको medical में interest है, so you can do that. If someone is interested in engineering, that is also possible. Then also computation, energy, जो solar panels बनते हैं उस पर भी research होता है. How do we improve the efficiency of solar panels? है ना? So that also comes under photonics. Consumer electronics. So Zeiss has developed lithographic devices, just devices that can print the integrated circuits, the phone. So if you recall, जो 2015 में phones आते थे, when I bought one, it was like I think 20 nanometer chip को कहते थे तब कि इसमें 20 nanometer का like chip है. What it means is that size of the transistor is 20 nanometer. Okay, and there are like billions of transistors chip में. Today, this laptop and this phone also it has 5 nanometer chip. छोटा छोटा. So like there is a Moore's law जो कहता है like every 2 years the number of transistors we can fit on chip doubles. ठीक है. So earlier it used to be like very big transistors in the chip. वो छोटा हो के now it is like 5 nanometer और atom के size के comparable हुआ है ना. So that technology was actually developed by Zeiss through the like 20 years उन्होंने spent किया, and then now they sell that device to make such chips across the world. So okay, so like the diverse applications are there. This is just one of those diverse applications. So some of the topics that people work in front of it are like system design, फिर वो micro and nanostructure optics भी काम करते हैं. I will explain this one by one. There are like combination of electronics and photonics, optomechatronical devices, and also precision optics. So first let me explain this one, then I will go to the next set. So first one, optical and mechanical design. So let's say we have to like construct this camera. Okay, so if we start directly manufacturing it and बाद में पता चला कि okay there was some problem with this lens, so image is not correct, है ना? So better is you design the system in simulations, computer simulations होंगे. So you design it and check how the light passes through the system. अगर उसमें कुछ for example scattering हो रहा है कहीं पे, then you can change the device like that component even before manufacturing it, है ना? So it is important thing to simulate your optical device even before manufacturing it. So it's a cost cutting होता है. You can experiment, you can improve the system even before manufacturing it. So these are here they have given like 3 examples. तो पहला तो है like eye tracking system, उन्होंने like simulate कर दिया पूरा And then there is some like analysis of scattering of light. So you can see here light is getting scattered. So ये component change कर दो तो the scattering will stop. You can improve the efficiency and so है ना. So this is also some objective उन्होंने simulate किया. So first research area is like simulating or designing optical system designing. Then also they manufacture भी करते हैं वो लोग वहीं पे. So this is like micro and nano structure. So can you see like this is probably like 5 to 10 centimeters circle, and on that they have printed some structures. So ये example है यहाँ पे इन्होंने इस chip पे they have like printed some of the material. ठीक है, and this is just one square का भी like minute part it is, this thing here on the left. So इससे होता है कि what we can do with this is like many applications in astronomy. अगर कुछ like light आ रहा है बहुत सारा तो उसको filter करने के लिए noise filtration, then you can also have like this is also important thing to compress short pulses. Ultra short pulses होते हैं laser की. So shorter pulse we can analyze system, faster system. मतलब होता क्या है, so let's say when you shine light on some atom तो excite होगा है ना, और फिर कुछ टाइम बाद it will relax back to its position. So if there are some systems which excite and relax extremely fast, you know, to study those kind of system you have to have very ultra short pulses. So using this methods you can have ultra short pulses. जो existing pulses है उसको भी वो compress करता है. Then we can have lenses, micro lenses. So it's like on this square you can have very micro level like 10 micrometer or like big lens. जो lens हम बड़ा देखते हैं, like this is also lens, right? We also have micro lenses and other filter structures. This is another topic. One more is that surface coatings. So Fraunhofer has expertise in making extremely fine surfaces. So have you heard about this James Webb telescope? सुना है? It was launched like 2-3 years back, and it is, I think, by far the best telescope we have launched. You know? So it was equipped with this MIRI, mid-infrared instrument. Okay? Mirror of these instruments were manufactured by Fraunhofer and also coated. So जो like we have to have very precise coating. एक भी nanometer का, like nanometer is like 10⁻⁹ right? उसका भी defect आया, then it like ruins your system. पूरा like telescope बिगड़ सकता है. So that level of precision you have to have. So they made this mirror systems. Also they made this near infrared spectrograph. ये भी device था जो इसके calibration में use होता है. They also made this. So this was for functional surfaces and coatings. Okay. Then there is precision optical components and system. So आपको ESA पता है? ESA, just like NASA, there is ESA, European Space Agency. Right? So last year उन्होंने launch किया था JUICE mission. So उसमें they are going to study actually moons of the Jupiter. Moons, the Jupiter के around moons. So the telescope in that mission was made by Fraunhofer. So this is the laser altimeter gala they have, like mirror telescope it is. They built it. Also, they have lasers and fiber technology. So when we think of laser, we remember that Chota laser which we used to buy from like, you know, not that thing. Laser systems are pretty big, and also you have to have वो तो बस visible light का laser था, red, we used to see red or green, but you can also have lasers in like infrared domain. So the optical cables that you see, जो Geo fiber हो गया, Airtel fiber, जो भी fiber systems है, they don't use visible light inside. They use this 1550 nanometers होता है, communication wavelength is 1550 nanometers. We cannot see it. So उस wavelength पे भी laser we can develop. Okay. So laser systems and the fiber technology. So यहाँ पे भी you can see, or the first step is to design. You have to design the fiber. Like manufacturing से पहले भी design करके देखते हैं, okay, will it work or not at this wavelength? Will it be efficient to transmit the light or not? You know? So simulations, design happens, then they decide on materials. ये पूरा जो system process like it happens at strong operator. And they also choose material. They make this kind of this big preforms और उससे और fiber draw करते हैं. And after making, they integrate it with the system. And the end, like the size of the fiber at the end, is around 100 micrometer, 200 micrometer. 1 millimeter से भी छोटा, it will be very small. So this also happens. Then they also perform imaging and sensing. Imaging is like imaging, like if I take a photo, it will give visible spectra. Right? You can also perform it in other wavelengths. So firstly, this is one of their 3D scanners. You can see the live scanning is happening. It is smart enough to understand like your eyes and facial structures. And also they perform, they create this kind of devices like on the specs. I can see this kind of information. They also work on that. And this was in visible spectra. You can also have it in like infrared and all. So this is lidar technology actually. जो भी like cars होते हैं, they can scan around themselves and see if there is some obstacle, human, other cars. So this image, you see, this is in dark actually. This was taken with night vision camera. Visible में तो नहीं दिखेगा रात में, but you can see in other spectra like infrared में दिख जाएगा. They have like infrared camera systems, imaging systems as well. This is also similar to that, like dividing the components as per the colors. So, and sensing is like, yeah, just like this. We are sensing there is some obstacle, there is some object here on this side. Right? So, imaging and sensing they also work on. One of the best applications for imaging is that. So let's say, so this was taken from their one of their telescopes. They had device on that telescope from the space, and ये तो visible like visible spectra में image लिया. Here is Jena actually, or there is Elfoot city nearby. So they just took some image of the ground, but we don't get much information out of this. But if you look at other range of the spectra, so we can get like rich information from the same image, from the same system. So you can see here now they can also find out the okay, this land will be more fertile for farming, and also they can have weather predictions better in other range like visible range के बाद if we see we can predict better the weather, land fertility, all the like nutrients in the soil and so on. So yeah, more information is present in the other spectra, and they also work on this. Then they have emerging technologies like the future of the technologies. So most of the emerging and for the future technologies are related with quantum mechanics as expected. So first one is like quantum communication. So like when we are calling through this phone, जो भी signal transfer हो रहा है, actually anyone can capture it, and if they have enough tools, वो decode कर सकते हैं. Okay, like if they get the encryption key, they can decrypt the message. But if you use quantum properties, so it is having more details. Let's not go into that. But yeah, quantum mechanics से advantage रहता है, using which it is not possible to decrypt at all. Okay, it's impossible to decrypt. So they are using this quantum advantage to have to set up communication. They are also trying to build quantum internet. Okay, so this is one thing. Then there is quantum imaging as well. So this is also like what do you say, interesting thing. So in that they produce entangled photons. Entangled photons क्या होते हैं? You will have some crystal, एक non-linear crystal, for example, this you excite it with some laser, और output में जो light आएंगे, like there will be two photons, let's say, they will be entangled, meaning they will be connected. So let's say they are generated here, but if I transfer them, let's say to other city, Mumbai and Pune, still they will be connected somehow. You can check on it, quantum entanglement it is. Okay, so using that property, we can image objects even without interacting with it. So not the topic of today, but then yeah, quantum imaging, it gives advantage over regular imaging. And there is quantum computing, like I discussed before, like computing we can सकते using quantum properties using light, and also the sensing and meteorology. Just like imaging में हमने देखा था sensing, how we can sense the objects, and also this metrology means actually calculation, precise calculation. For example, you have some chip and you have to find the width of that chip. So we can uh, calculate that width to the like nano level that हम precision रख सकते हैं. So this earlier I said we can detect single photon. That is part of like sensing and metrology. You can even sense even like single photon, and so that is also possible. And in emerging technologies, the one thing people are behind is the quantum computing. And how is it happening is through this kind of chips, जिसमें they have integrated or printed very tiny circuits, optical paths actually, optical paths. So like light can enter through here and interact with some other light, and then in the output, we will detect it and perform some measurements. So on the right side, you see uh, this is micro ring. Okay, it is very tiny actually. You can see this is like finger and उसपे भी एक इतना सा है. And on that you have to look through the microscope and you can see this kind of rings. The diameter of these rings are like 100 micrometer or even smaller. Micrometer, okay? And yeah, so light interacts in this path and then अलग-अलग properties होती है. For example, the one that I'm working on is quantum random number generator. Okay, so उसमें होता क्या है? Light comes into this kind of rings, and when it goes out, उस light का जो phase होगा, like electromagnetic wave है, उसमें what are the two properties of wave? Amplitude and wavelength or the phase, phase भी, yeah. So जो phase होता है output में, it will be random. Either it will be zero or it will be pi. So we can use this to have a random number generator. Okay, random numbers are used in communication for security purpose. You can check on it. The use of random numbers in cryptography. So yeah, so the project that I'm working on is like to generate quantum random number generator, and there we use this kind of light properties. Okay, so yeah, like, and there are और भी topics है photonics में, तो बस like 7-8 topics I could discuss in this like half an hour, but it is much more diverse, and whatever your interest is, engineering, medical science, pure science, there is place for you in photonics. So let's discuss career opportunities in photonics, like how can you join photonics in future. So फर्स्टली इट इज ओपन, लाइक आप बैचलर्स लेवल पे भी ज्वाइन कर सकते हैं. इफ यू डिड बैचलर्स समवेयर ऑलरेडी, देन आप मास्टर्स लेवल पे भी ज्वाइन कर सकते हैं. और इफ यू ऑलरेडी हैव मास्टर्स, यू कैन आल्सो ज्वाइन एज PhD. And people from all the backgrounds, अभी जो मेरे बैचमेट्स हैं, they're coming from, some are coming from pure science, some are engineers, some are coming from biology background, है ना? So we can have like degrees, bachelors in or masters in physics, chemistry, biology, mathematics, no problem. You just have to find correct interest or problem in photonics, है ना? Even if you're from like electrical engineering, it is possible. Medical biology B, it is possible to join photonics even if you have degree in biology or medical. And these are just some of the jobs that is like happening these days. So if I've taken this from jobs.sonofa.de, and so you can see the type of jobs, the type only, like कैसे jobs होते हैं वहाँ पे. So there are like people working on like जैसे optomechatronical components का हो गया, या फिर this list is not having students के लिए भी possible होता है. Like currently my visa is still student visa, right? Still I'm working, I'm able to work. So like this, you can also work while studying. So like there are three big, just not big, but then Actually, there are so many cities outside India which are focused on photonics, but only three of them are like Vienna, Germany में है, Eindhoven, Netherlands में है, Hamamatsu, Japan में है, okay, and these are their master's program. The first university, that's where I'm working, at the School of Photonics. Second is Karlsruhe Institute of Technology. Then there is also Max Planck School of Photonics. Max Planck, do you know? Right? Planck's constant. That Max Planck. Yeah. Then we have Eindhoven University, which is in Netherlands. You can check out these links. I will share this with you. So, but I would like to focus on Germany because, firstly, there is no tuition fees in public universities. Like you don't have to pay. If you go to US, Canada, the fees are very high, like 20, 40 lakh तक जाता है for 2 years. Right? So in Germany, it is good. If you are going to study abroad, don't go to private universities. कभी भी मत जाइए. It will be very expensive. Go to public universities. Public are like government universities. Go to public universities. There will be very low or no tuition fees. And also, good thing about Germany is like you can work while studying. Also, in some of the universities, there is no restriction on course duration. Like हमारे यहाँ होता है, we have to finish the course in 2 years, otherwise like it is not possible. But then you can take like 8 semesters, 10 semesters. लोग like 3 4 साल लेते हैं to complete just one degree because they want to focus on just one course, one topic at a time. उनको अच्छे से काम करना है and then they will finish at their own pace. That is also possible. Uh, on an average, like you will have expenses of 12 lakhs initially. That is also like your own expenses, like rent and food and stuff. And after that, in first year itself of your degree, let's say you're doing masters, you can start some job, and then like in second year you'll be independent. You don't need to get money from home. And also you will get industry level skills. So Germany ka like benefit is that academic studies are in line with industry. जो भी industry problems है, it will be taught in your course. The course में सिखाएंगे कि okay, this is the problem and you have to work like this, you have to study like this. So industry level skills you can acquire while studying itself, and जो degrees होती है, like it is valued by their industry. Like if I say that okay, I've done this masters from this university, some company will really hire me just on that basis. Okay, he has completed this masters in photonics. So we will quickly, I would like to show you this link. I will just visit this thing here. Okay, so if you visit that link, this is DAT. It is German Academic Exchange Service. So जो भी courses होंगे Germany में, it will be cataloged here. But even if you want to search like other courses, not photonics, other things, you can search. So let's search photonics here. So when we search it, we will find like all the list. जो भी courses है photonics में, you can find it here. Also on the left side on top, we can select the course type. For example, if I just search physics here, or then I can choose bachelor's, master's, PhD. Let's say I want to search for PhD. I just select it, and then you can find the topics. All the PhD programs are linked, catalog on this website. So really good website, and also you can let's go back to photonics. And also let me unselect this. So see, the first one is like Munster University of Applied Sciences, Steinfurt. You can see that there is no tuition fees, okay? And duration is like usual 4 semesters. Subjects available at this. Language is in English. Also, this is my program. That's where I'm studying Masters of Science in Photonics, University of Jena. Again, no tuition fees, 4 semesters, English, like this. You can search on this website. यहाँ पे आपको स्कॉलरशिप का भी डेटाबेस मिल जाएगा. You can search like that. Okay. And this was it. And also I will show you this website. This is like after you go there, just check on jobs.fraunhofer.de. So आपको like पूरे जो जर्मनी में Fraunhofer only for Fraunhofer Fraunhofer institutes के जो jobs है you can check. So let's say if I go here, this is Jena here, and currently there are this kind of jobs opening. Scientific researcher. You can also maybe find some student positions with it. Okay, अभी तो नहीं है शायद. But yeah, like this you can find. This is for Fraunhofer. Also, then there is AB School of Photonics. Let's say you have to apply for Masters in Photonics. So आप आओगे इस वेबसाइट पे asp.union.de, and yeah, you can see there are like MSc Photonics, MSc Quantum Science and Technology, MSc in Physics with focus on Photonics, medical photonics like I mentioned earlier. You can check out these courses. You can check out the research happening there. So you can see these are the research topics. Let's say I go to ultra optics. You can find out all the research areas that they have. Same format आप कोई भी यूनिवर्सिटी के साथ कर सकते हो. Just search university that you like, go to their website, check out the programs, masters or PhD level programs, check out their research like this. So this is for Abyss School of Photonics and their research. And then we have Zeiss Group. So here is like what's happening at Zeiss. You can check out their research as well. You can go to here the careers at Zeiss, and you will find all the like type of, if you want to go to research and development, you can check out the topic that they work on. So just like whatever we discussed today, just remember this 3-4 things, that the kind of research happening in photonics, okay, and good research of it is happening in Germany, and these are the ways you can also follow to get into photonics. And then that's all. Thank you for attention. If you scan this code, आपको ये जो presentation था उसका PDF you can download. So just scan it, download it, keep it safe. Thank you so much for your attention.
थैंक यू सो मच अक्षय सर फॉर अ वेरी नाइस एंड इन्फॉर्मेटिव टॉक. तो अभी आप में से कुछ लोग मे बी यू मे थिंक ऑफ ज्वाइनिंग बैचलर्स डायरेक्टली इन जर्मनी समवेयर, वो भी ऑप्शन है. तो देर आर करियर अपॉर्चुनिटीज़. बहुत सारे लोग 12th के बाद भी जाते हैं टू डू देयर बैचलर्स आउटसाइड. आई हैव सम फ्रेंड्स जिन्होंने वही किया, दे वेंट डायरेक्टली फॉर बैचलर्स. प्रॉब्लम यह है कि वी आर नॉट अवेयर कि वहाँ पे जाना कैसे है, कोर्सेज कौन से है. So hopefully it has helped you a lot. So let us thank Mr. Akshay once again. Thank you, sir. Yeah.